Oxidation, reduction and redox equations. First of all, we need to work out something called an oxidation state. An oxidation state is how many electrons an atom may lose or may gain. So let's have a look at our periodic table that you have a copy of it in an exam. Elements in group 1, like lithium, sodium and potassium, have 1 electron in their outer shell. What will they do? Well, they'll lose 1 or gain 7, so they choose to lose 1. That's easier than gaining 7. So if they lose 1 electron, an electron is a minus. If they lose a minus, they become plus. So the oxidation state of lithium, sodium, potassium, losing 1 electron, losing 1 minus, is 1 plus. They would form 1 plus ions. Elements in group 2, 2 electrons in their outer shell, gain 6 or lose 2, they would lose 2. If they lose 2 electrons, they would become 2 plus. These elements, beryllium, magnesium, calcium, strontium, barium, radium, would have an oxidation state of plus 2, lose 2 electrons, lose 2 minuses. Let's look across to the right hand side. Elements in group 0 or group 8 don't want to lose any electrons at all. They've already got full outer shells, their oxidation state is 0. Elements in group 7 lose 7 or gain 1, they will gain 1, so fluorine, chlorine, bromine, iodine would gain 1 electron, gain 1 minus, their oxidation state minus 1. Elements in group 6, oxygen, sulfur, lose 6 or gain 2, gain 2, gain 2 minuses, they would be minus 2 oxidation state. The ones in the middle, not including this block, which doesn't seem to be in any group whatsoever, they're called the transition metals. The ones in group 3, 4, 5 are a little bit harder to determine. We're going to look at those now. So, hydrogen. Hydrogen, if we go back to our data sheet, our periodic table, is in group 1. It should really be over here, but it's in group 1. It's got 1 electron in its outer shell. It's in group 1, would form plus 1 oxidation state. Oxygen in group 6, gain 2, 2 minus, minus 2 oxidation states. And they're really good as references because they always form that. Lithium, sodium, potassium in group 1, oxidation state plus 1, would lose 1 electron. Calcium, beryllium, barium, strontium, always oxidation state plus 2, lose 2 electrons. And group 7, F, Cl, Br, I, always gain 1, would be minus 1. Harder to determine are things like carbon that's in group 4. Does it lose 4 or does it gain 4? If it loses 4, it will be plus 4 oxidation state. If it gains 4, it will be 4 minus oxidation state. And that's where we need to work it out. So we use some of these as references, and then it's just simple maths. I want you to calculate, work out what the oxidation state of the underlined element or atom is. So let's do the first couple, or I'll pick some at random. Number 1, oxygen. So we'll use that as a reference, oxidation state minus 2. So something, the carbon, minus 2, leaves no charge overall. So what number minus 2 equals 0? X minus 2 equals 0. X, which is the oxidation state of carbon, the unknown number, therefore is plus 2. Because plus 2 minus 2 leaves no charge whatsoever. Let's try number 2. S. Well, I've got oxygen at minus 2 oxidation state, but there are 2 oxygens. Minus 2 and another minus 2 is minus 4. So those 2 oxygens together are minus 4 oxidation state. There's no charge overall, so I'm looking for something to balance out minus 4. Sulfur is in plus 4. X minus 4 equals 0, no charge overall, so S is in plus 4. Plus 4 minus 2 leaves no charge. Let me hop to number 4 now. I want to work out nitrogen. And it's got 3 H's, 3 hydrogens. Well, a hydrogen is plus 1. So 3 hydrogens plus 1 plus 1 plus 1 plus 3 together. Something plus 3 gives no charge overall. So nitrogen is in minus 3, because minus 3 plus 1 plus 1 plus 1 is no charge overall. Let's just hop to a couple more difficult ones then. This one here, CO3 2 minus. Well, we know oxygen is minus 2, and there are 3 oxygens. Minus 2, minus 2, minus 2, 3 of them is minus 6. So these 3 oxygens are in minus 6 oxidation state altogether. But there's 2 minuses left over. So something, the carbon's oxidation state, minus 2, minus 2, minus 2, leaves minus 2, 2 minus overall. So X, which is the oxidation state of carbon, minus 2, minus 2, minus 2 equals minus 2 left over. X minus 2 minus 2 minus 2 equals minus 2. X minus 6 leaves minus 2. So carbon is in plus 4. Plus 4 minus 2 minus 2 minus 2, or plus 4 minus 6 is minus 2 overall. Let's hop to number 12. That's a bit trickier. This is possibly one of the hardest ones. 7 O's. Oxygen is in minus 2 oxidation state. Those 7 O's, 7 times minus 2 is minus 14. So each oxygen has minus 2 oxidation state. 7 minus 2's is minus 14. So the 2 CR's minus 14 leave 2 minuses left over. So X minus 14 leaves minus 2. The 2 CR's are minus 12, plus 12 together. Plus 12 minus 14 leaves minus 2. So the 2 CR's together are plus 12, but there are 2 of them. So each CR is plus 6. You take the plus 12 and divide by 2. Let's just work that through. Each CR is plus 6 plus 6 plus plus 6, because there's 2 of them, is plus 12. 7 minus 2's is minus 14. Plus 12 minus 14, 2 minuses overall. See if you can work out the oxidation state of the underlined element 1 to 27. And we'll come to this part, reduction, oxidation, and this section in the next lesson.